lesson 2.6, we're going to look at graphing several different types of special functions. Step functions, constant functions, identity functions, absolute value functions will be some of the ones we'll look at. First thing we're going to do is we're going to look at a step function. Basically, a step function is named a step function because its graph is going to look like steps. Here's an example of a step function graph, or we'll graph this, which will look like a step function. One psychologist charges for counseling sessions at the rate of $85 per hour, or any fraction thereof. Draw a graph that represents this situation. So I'm going to title a column here, the number of hours. Or a column. And I'm going to say, if we do 0 hours, what's the charge? I'll just put the dollar amount. Well, if I don't do any hours, it's 0. So we know at 0 hours, the charge is 0. So there's a point there at 0, 0. If I go from 0 to 1, in between, so 0 is less than h up to 1. Now, I'm not going to include 0 on this interval, but I want to look at ones that are between 0 and 1, from hour 0, any fraction of an hour, half an hour, 3/4 of an hour, whatever. Well, then it's going to be $85. So that means for everything in between 0 and 1 hours, we're going to be up at $85. Okay, now what I'm going to do here is, because at 0, we were down at 0, 0, I'm going to draw an open circle at 85 on the vertical axis. And then we're going to be at 85 for everyone in between here, all the way over, including 1 hour. Okay, and there's going to be a closed circle right there. So everything in between, not including 0, we're at $85. And then we're going to look at what happens from 1 to 2 hours, or in between 1 and 2 and including 2. Well, now it's 85 times 2. Okay, even if you go for an hour and a minute, you're going to get charged for that second hour, which is equal to $170. So basically everything from between 1 and 2 is $170. So we're going to have an open circle in between 1 and 2, and we're going to have a closed circle. Then between 2 and 3, so we're looking at intervals here, between 2 and 3, we're going to get charged for that third hour, which is 85 times 3, or $255. So between 2 and 3, we're going to be at 255. So it's going to be an open circle. Can't be a closed circle, because then I'd have 2 different points for 2 hours, over to a closed circle right here. And between 3 and 4, we could put another interval on, but that will go off the grid that I gave you. This is called a step function. Its graph looks like steps. Some other things that produce step functions is greatest integer less than or equal to. And what you're going to do with this is this is called a floor function. It's going to produce a step function graph, but it's a floor function. You're going to round down to the nearest integer. Okay? This symbol right here, okay, means whatever's inside there. If you follow order of operations, you round down to the nearest integer. It's kind of got double bars on either side. So what we're going to do is we're going to make tables here. Let's actually move this over. Oops. Let's cut that out. I'm going to move this. That's the greatest integer symbol. I'm going to move it over there. And we're going to make a table here. So I'm going to make an XY table. And I'm going to call it X and F of X. Remember, F of X is like Y. I'm going to pick some negatives. I am actually going to start at -4. So if I plug -4 in, I have 0.5 multiplied by -4 inside of here. So I have 0.5, and then inside my greatest integer symbol, I'm sorry, it's in 0.5 is in there as well. So inside the greatest integer symbol, is 0.5 times negative 4. 0.5 times negative 4 is negative 2. So I get a negative 2 inside there, and then it says round to the nearest integer. Well, negative 2 is an integer, so that gives me negative 2. I'm going to leave a little space here, negative 3, but we need to look at what happens in between negative 4 and negative 3. So I'm going to pick one decimal in between there. To make it easy, I'm going to pick negative 3.5. If I go in between here, I got 0.5, and I'm going to change this to negative 3. So I have 0.5 multiplied by negative 3 inside there. I got to do that multiplication, which is negative 1.5, and then you round negative 1.5. This says greatest integer less than or equal to. You round it down. The integer below negative 1.5 is negative 2. This means that basically everything between negative 4 and negative 3 is going to round down to negative 2. But if I go to negative 3, I put negative 3 in there. And that actually will be negative 2 as well, because you have negative 3 times a half, that'll be negative 2. If I put negative 2.5 in there, negative 2.5, if I multiply negative 2.5 by 0.5, I get negative 1.25, but round that down to the integer below negative 1.25, which is negative 2. So pretty much all four of these, okay, went to negative 2, to a y value of negative 2. Now I'm going to go down to negative 2 here. If I put negative 2 in for x, I take 0.5 times negative 2 inside that greatest integer less than or equal to function. That would be negative 1. I round it down. I'm going to get negative 1. If I try negative 1.5, multiply that by 0.5, I get negative 0.75, but then I round negative 0.75 to the integer below it, which is negative 1 also. Put negative 1 in. Negative 1 times 0.5 is negative 1/2. Negative 0.5 rounded down will also be negative 1. Let's put in negative 1/2. And again, I'm just trying one decimal in between integers, so I'm trying the one that's in the middle. But that means for all of those it would be the case. So negative 1/2 times 0.5 is negative 0.25. Round to the integer below negative 0.25. Your choices are either negative 1 or 0. You're going to round it down below it to negative 1. If I put 0 in, 0 times 0.5 is 0.5, or is 0, excuse me. Rounded down would be 0. If I put in 0.5. 0.5 times 0.5 is 0.25. Round to the integer. What's the integer below 0.25? 0. If I try 1, 0.5 times 1 is 0.5. The integer below 0.5 is 0. Try 1.5. 0.5 times 1.5 is 0.75. The integer below 0.75 is 0. You can kind of see the pattern here. I'm going to continue with my table over here, x and f of x. And let's switch colors again. So I'm going to try 2. When I put 2 in there, 2 times 0.5 is, or 2 times 1/2 is 1. And round to the integer. Well, it's already an integer, it's 1. If I put 2.5, 2.5 times 0.5 is 1.25. Round it down, it's 1. If I put 3 in, 0.5 times 3 is 1.5. Round it down. If I put 3.5, you can kind of see the pattern here and see what's going on. If I put 4 in, 4 times 1/2 is 2. Round it to the integer, well, that's going to be 2. So actually, let me use a different color there. So let me use red. That's going to be 2. 4.5 would be 2. 5 is going to be 2. 5.5 is going to be 2. And notice at 6, I would jump up to 3. So what does this graph look like? At negative 4, we're at negative 2. So we're right here. At negative 3.5, we're at negative 2. At negative 2, or negative 3, we're at negative 2. At negative 2.5, we're down here at negative 2. Okay, but then at negative 2, we actually jump up to negative 1. So what that means is I have a closed circle right here. So this one needs to be closed. and then all the numbers in between here over 2, but not including, and then that's going to be an open circle. So basically the numbers between -4 and -2 are all down at -2. And then it jumps up, and then from -2, for x values of -2, all the way over to 0. At 0, we jump up to 0, right here. So what's going to happen is, and you're going to see the pattern here, it's going to go over to there, open circle. And then it jumps up. It's going to be an increment or a step of 2 length, and then it jumps up. Okay, and then for x values between 2 and 4, we're at 1. If you see all the x values between 2 and 4, up to 4, but not including 4, because that's where it jumps up. And then it's going to be over here to an open circle. And then it's going to jump up again, and this is going to continue, and this is going to continue. So it's a closed circle on the left over to an open circle on the right. Let's look at the next one. Now, this is different because the operation is outside. Okay, we're still going to make a table here. So we got x and f of x. So let's start with -3. If I put -3 in here, I round that to an integer. Now I got to round first and then subtract 2. Well, that's already an integer. That's going to be -5. Okay, -2, but we got to look at what happens in between. So I'm going to go -2.5. -2.5, if I put -2.5 in here, I round this to the integer below -2.5, which is -3. I subtract 2, it's -5. If I put -2 in there, well, I round that to an integer. Integer would be below it, would be, well, it's already an integer, -2. -2 minus 2, it's going to be -4. If I do -1.5, I round that to -2, because to the integer below -1.5, subtract 2, it's -4. If I go to -1, that would be -1 there, rounded to an integer. Then we're going to be up at -3. Excuse me, -0.5, round it down, so that would go to the integer -1. -1 minus 2 is -3. You can kind of see patterns develop in these step functions. At 0 and at 0.5, we're going to be at -2. Then at 1, we're going to be up to -1. At 1.5, we're going to be at -1. And then at 2, we're going to jump to 0. At 2.5, we're going to be at 0. Continuing over here with my x and f of x table. At 3, we're going to jump up to 1. 3.5, we'll be at 1. At 4, we'll be up to 2, and so on. It would continue. So at -3, we're down here at -5. 1, 2, 3, 4, 5. So we're right down here. At -2.5, we're at -5. But then at -2, we jump up here. Whoops, excuse me, that's in the wrong spot. But then at -2, we jump up 1 unit. So we have a closed circle here. So what's going to happen is this is going to be little shorter steps this time. We're going to go here, over to an open circle, and then we jump up. And then what's going to happen is in between these two, it goes here, open circle. It jumps up at -1. We're down at -3. 1 unit in length is our step over to an open circle. Then it jumps up a unit. 1 unit in length jumps up. You can kind of see the pattern here. And it's going to continue going on like that. That's a step function graph. Going back to this. Let's go back to the previous graph. I forgot to do one thing. If we go back to this, let's list our domain and range. Okay, now the domain we're trying, I only tried 1 decimal in between, but we're really trying all real numbers. So the domain is all reals. The range, notice the output values. We're jumping up 1 integer each time. So, and it goes on forever in the negative and positive direction. It would be all integers. So make sure you list domain and range. I forgot to do that on that problem. Now go into this one. Domain, again, is all reals, because we're trying everything, or we could try everything. It's going to, because we're rounding, the range is going to be all integers, or the set of integers. Now, sometimes, depending on the numbers involved here, you could have, integers that are multiples of 3, if the steps jump up every 3 units or whatever. It just depends on the given equation, or given function. Let's go to a constant function. In a constant function, constant means the graph's going to be a horizontal line. The graph is constant. Graph is a horizontal line. Notice this is f of x equals negative 3. That's like y equals negative 3. We've talked about y equals a number. No x on it is always a horizontal line. So y equals negative 3 would be this line right here. Horizontal line at negative 3. Domain and range. The domain is what x can be. It goes infinitely in both directions. Connected graph would be all integers. Or I mean, not all integers, all real numbers. The range, remember every point on this has a y value of negative 3. So the range would be just negative 3. And you should put that inside set braces. So anything that's a constant, f of x equals some number or y equals a number, would produce a constant graph. We'll look at the identity function. F of x equals x. That's like y is equal to x. Make a table. We're going to do a lot of tables here. And this is called the identity because y is equal to x. So if I have negative 3, the y value is negative 3 because they have to be equal to each other. Negative 2, it's negative 2. Now I don't really need to try decimals in between if I'm not dealing with the greatest integer function, that's less than or equal to. So I can just try my integers. Negative 1, it's at negative 1. 0, 0, 1, 1. These have to be equal. So 2, 2. 3, 3. If I graph these, negative 3, 3, negative 2, 2, negative 1, 1, 0, 0. So here's what your line, and this would be just a line then. This is called the identity because it splits the first and third quadrants in half. The identity because y is equal to x. Domain and range. This goes infinitely in the left and right direction, so the domain is all reals. The range goes infinitely up and infinitely down is also all reals. So that's an identity function. Remember, this is in y equals mx plus b form, so if you think about mx plus b, 1 over 1 is the slope, plus 0. Y-intercept is 0. Up 1, right 1 would be right there. Up 1, right 1 would be right there. So there's our line. So not just a way of tying it into mx plus b form.